And this is one of the last technical slides I have. It just gives a bit of an overview, very generic overview, what an SD-WAN could look like, software-defined wide area network. So we have different branch offices, we have a headquarter, they're connected using some degree of SD-WAN device with some encryption, so some privacy included, and they connect normally, or ideally, they connect to different access technologies. So IP MPLS for the high capacity SLA, QoS related traffic, broadband access networks for, let's say, best effort traffic, traffic with low priority that should not create a lot of cost, or use even 4G or LTE in case you don't have any fixed line infrastructure at the place you want to connect to the network. And on the other side, we do have some enterprise data center where some of the applications are hosted. We might have some cloud-based applications like the government's Salesforce or similar products, or you even have non-critical applications that you might use for marketing or just for fun, like YouTube and the likes. And all these devices are then controlled by something that we call a controller or a policy management device that define the rules, how your traffic is being managed, which type of traffic uses the IP MPLS, the expensive world, which type of the traffic goes through the cheaper world, broadband access, or 4G LTE traffic. And ideally, we also have some degree of analytics mechanisms that understand, okay, what is the load state of my existing infrastructure, so how much traffic is going through where, what is the price situation, what is the performance situation of my infrastructure, and then makes decisions on where to place the traffic. So that is the ideal world that a lot of SD-WAN vendors envision. So if we can do this, we can, for instance, guarantee quality of services and SLAs using our traditional IP MPLS VPNs. So we still leave a lot of traffic on the traditional infrastructure that will allow us to have a good performance, but we could also offload traffic that does not need to be sent across an expensive infrastructure, so low-value traffic, I'll put it like this. We can send this traffic through a different direction. We don't use the MPLS infrastructure, thereby freeing up capacity or even improving the quality. We could also use WAN optimization technologies to even squeeze more capacity out of the existing WAN that we have. The idea is to reduce the cost per megabit overall, because if we only, let's say, use 100 megabit on MPLS as we had before, 200 or 300 megabit, and we use the other 200 megabit and shift it over to broadband access or LTE. Ideally, we have mechanisms in place to do this automatically, so we have some means of automating the provisioning of the services, and we do have some central policy enforcement that makes sure that the traffic follows the policy rules we define. Ideally, everything should be easily configurable. You should not have deep technical knowledge to operate these kind of infrastructures. There's still some things that might not be working out pretty fine because you lose a bit of control if you hand over traffic to broadband infrastructure. You use this broadband infrastructure as an over-the-top service. You are the over-the-top service. You don't have any control of the underlying infrastructure. So you lose visibility, you lose some degree of manageability, and of course, it's getting a bit more complicated to troubleshoot if something goes wrong. And of course, securing a very distributed environment is always a complex undertaking. So it requires a bit additional efforts in planning this and making sure that it's going to work.